yellow, and blue. And that gave rise to what's known as the trichromatic theory of color vision. It's not quite right, but that's what they were working with for most of the 19th century, which basically began with the psychological observation that all visible colors can be produced by a mixture of really just three basic colors, red, green, and blue, or red, yellow, and blue. And that gave rise to the speculation that there were three kinds of cones in the retina of the eye. We knew the cones were sensitive to wavelength in a way that rods are not. Three kinds of cones, one sensitive to short wavelengths, one sensitive to long wavelengths, and one sensitive to wavelengths that are in between. Again, what you're seeing here is an attempt to connect the mental with the physical and the mental with the physiological. Now, the trichromatic theory was eventually replaced by what's known as the opponent process theory, another thing we don't have to go into. But the basic idea here is that these primary colors, red, green, yellow, and blue, are basic qualia of the experience of color. You can't analyze them any further than that. Let's take this a little bit further. James Cutting, a perception psychologist at Cornell, has argued that these primary colors, red, yellow, green, and blue, are models for what we would want to look for in other sensory modalities for basic qualities. Okay, and he noted that these primary colors have some very, very, very interesting properties besides their physical ones. First, some mixture of red, yellow, green, and blue will yield all other qualities. Okay, so that's what you really want to have if you've identified a basic quality of experience. You want to have one where you can mix them up to produce all the complexities of the experience of color. Second property of these basic colors is what Cutting calls physiological attunement. That is to say, there appears to be something like a unique neural pathway for each of these sensory qualities. Short wavelengths stimulate different receptors than long wavelengths. Medium wavelengths, different receptors as well. But it's not just physics and physiology here. One of the things that Cutting notices about these basic qualities of color is that they are monolexemic. That is to say, they are represented by single words, monolexemic, and words that have a high frequency of use in language. If you analyze a corpus of language, you'll find red, yellow, green, and blue used a lot. Purple, violet, indigo, orange used a lot less often. And that, again, that's a hint, a linguistic hint, that you're dealing with some kind of primary quality of sensation. But it's not just that either. For example, it turns out that red, yellow, green, and blue are basic color categories that are encoded in most languages. And Professor Berlin here at Berkeley and his colleagues have done cross-cultural studies looking at color terms in various kinds of languages. And it turns out if there is a language that has just two color terms, those color terms correspond to light and dark. Okay? If they add yet another color term, that color term is either red or yellow, or green and blue. If you add yet another term, what you add is green and blue. So all languages that have four color terms have red, yellow, green, and blue. Okay? They may have four color terms. They may have more than four color terms, but they all have words for red, yellow, green, and blue. And then finally, again, this is a linguistic property of these basic quality, what Cutting refers to as entomology. Notice that the words blue and yellow and green don't refer to any object. They just refer to themselves. Okay? You would never say that's a red. Well, you might if you were a color nut or something. You say, oh, that's a kind of a red. But you don't say it's the red. Okay? But there are oranges that are colored orange. There are violets that are colored violet. And there are olives that are colored olive green. So those colors refer to objects that have that color. But red, yellow, green, and blue don't refer to any kinds of objects at all. So the general idea that Cutting proposes is that if you want to go to other modalities of sensation, audition, gustation, olfaction, and so on, and find out what the basic qualities of sensation are, they probably ought to have these kinds of properties. They ought to be, there ought to be some kind of physical mixture associated with them. There ought to be some physiological attunement. Your basic qualities ought to be represented by single words. They ought to be encoded in most languages, and they ought to refer to nothing but themselves. You know a basic quality of sensation if you saw those kinds of features. With that in mind, and very quickly, let's look at the contributions of late 19th century structuralism, where they tried to use experimental introspection to identify just what these basic qualities are in various domains other than vision and audition. So, for example, there is a wide literature on the basic qualities of gustatory experience. And the general consensus up until relatively recently was that all tastes, all flavors, could be decomposed into 4 basic qualities of taste: sweet, sour, salty, and bitter. Later on, when Japanese and Chinese food became popular, they redid these experiments and discovered a 5th basic taste known as umami, or savoriness, that's really not derived from sweet and sour and salty and bitter. But that's the point here. When you ask me, well, what does umami mean? Say, I can't really tell you what it means. It means really good taste. Or it means savory, or something like that. What's savory mean? Well, it means umami. It means really good taste. It's got that kind of ineffability to it that you expect for basic qualities. But again, the idea here is that all the various things you taste by virtue of some combination of sweet, sour, salty, bitter, and umami, and hypothetically at least, on the taste buds of the tongue, you've got different structures that are geared to whatever it is that gives rise to those tastes. Moving very quickly, you can do the same thing with olfaction, and you get 6 fundamental qualities of olfactory experience: spicy, fragrant, ethereal. There's a good one. Define ethereal. Okay, that tells you you've got a quality. Okay, rosinous, putrid, and burned. Never mind that. You've also got qualities of touch. If you ask what things feel like, sandpaper, silk, cotton, wool, or whatever, what you get is a set of relatively monolexemic terms like tickling, pricking, straining, neutral pressure, and so on. Not quite right, not exactly monolexemic, but again, trying to decompose these various kinds of qualities so that what makes silk feel different from cotton, feel different from wool tweed, is that each of those sensations, each of those complex sensations, consists of some combination of more basic sensations. Okay. That's the general idea behind the scientific investigation of qualia, to assign numbers to these things, to try to analyze them into their basic elements, and then finally to try to find their physiological correlates. That's the basic program for scientific introspection. Next time, we'll talk about the mind-body problem. Thank you very much.